Okay, this is my access switch 1, this is my access switch 2. Okay, in my network I have two VLANs or three VLANs assume. Okay, one VLAN belongs to HR department, second VLAN belongs to sales department, third VLAN belongs to IT department. Okay, now this particular VLANs has a PCs connected, right? A VLAN will have some endpoint connected. Either it can be a PC or it can be a laptop, it can be printer, whatever it is, they would be connected, right? Suppose these VLANs are divided between other locations. There is no specific place where the user would be sitting. You would be having a big hall. Anyone can be sitting anywhere, right? So suppose I have this particular PC here belongs to HR1. Then I have another PC in the same switch. I have for a sales. Then in the same PC, I have another switch, another PC with another department, which is IT department. Okay. Similarly, in this switch also, I would be having different PCs available. Okay. HR2, sales 2. Then I would be having a different, which is IT2. Remember what we have discussed in the last class? Access port. Access port carries single VLAN traffic, one VLAN traffic. Now, usually what I will be doing in a configuration, this would be part of my access port VLAN. Suppose HR VLAN is VLAN 5, sales is VLAN 10, IT is VLAN 15. These are the VLANs I have created in my switches. Then access port would be part of VLAN 5. Then sales port would be part of access VLAN 10. Then IT port would be part of access VLAN 15, right? Similarly, here I would be doing again access port part of VLAN 5, sales port access VLAN 10, then IT port access VLAN 15. Now, as my VLANs are segregated between the departments, okay? Now, suppose HR to HR communication I wanted to do, sales to sales communication I wanted to do, or IT to IT communication I wanted to do. Here, if I create a access port, I would be having access port would be carrying single VLAN traffic, right? Access port cannot carry multiple VLAN traffics. If I give VLAN 5 access port, HR to HR communication will easily happen, but other communications will not go. This cannot communicate with this PC or this cannot communicate with this PC. Correct? So to overcome these solutions, we have one technology, we call it a trunking. What trunking will do? Carry multiple VLAN traffics. Okay. So how it will happen? Let us understand now. 1 minute, hold on. This let me remove. Okay. So as soon as I create a trunking protocol here, this would be part of VLAN 5, 10, 15 or whatever VLANs we have. No? This will be part of all the VLANs. Okay. Now, when the HR is sending a traffic, what trunk will do? It will do a trunking a tagging. Okay. What protocol we will use for tagging? We will come to a later. A switch will do a tagging. Then if a HRPC is sending, our packet will have a VLAN 5 tagged and it will reach to our switch. A switch will again do a untag, then send it to only VLAN 5. Similarly, when the sales PC is sending, the new tag will be added like a VLAN 10. When IT PC is sending, another tag will be added like a VLAN 15. Okay. So let us go to a theory of trunking once. Trunking. So what trunk will do? Trunk protocol carries traffic of multiple VLANs. When we have a same VLAN PC across different switches, trunk port helps to enable communication. By default, all VLAN traffics are carried over the trunk port. Okay. Now let us go down. Any questions in this? How trunk port, why we will use a trunk port, how it carries the traffic, we will go into a deep in a couple of minutes. So let me go to one small lab and we'll show you. Let me take two switches, switch 1, switch 2. Let me take 3 PCs. 1, 2, 3 here. 1, 2, 3 here. Okay. Let us connect each of them. Okay. Okay. Now let me configure VLAN 5, VLAN 10 and VLAN 20. First let me give a IP address. VLAN 5. This PC will have a IP address of 192.168.5.1/24. Here also VLAN 5 PC 192.168.5.2/24. Okay. Then here I would be having a VLAN 10 192.168.10.1/24. Sorry. Here also I would be having a VLAN 10 PC. Then here I would be having a VLAN 15. So I will change this. .15.2. Okay. Okay. Now let me configure VLANs in a switch 1 and switch 2. How to configure VLANs we have discussed in a last class, but still I will show you. Enable mode, then config terminal mode. Then just give a VLAN 5, name HR, VLAN 10, name sales. Name is not a mandatory command, it's optional. And then VLAN 15, name IT. Okay. I have configured a VLAN. Now I need to configure access ports. If you see as per our diagram, this port F0/2 access part of VLAN 5, F0/3 access part of VLAN 10, F0/4 access part of VLAN 15. Okay. As of now, I will only configure access ports. I will not configure trunk ports. Interface fast Ethernet 0/2 switch port mode access, switch port access. See, first we are saying this port would be access port. Then we will say it port should be part of which access port? VLAN 5. Then same interface fast Ethernet 0/3 switch port mode access. I am saying the port will be part of access. The port is a access port. Then switch port access part of VLAN 10. Then switch port mode access. Then sorry, interface fast Ethernet 0/4 switch port mode access, switch port access VLAN 15. Okay. All the three ports I have done a access port VLAN configured. How can we check this? Show VLAN brief. You see, port number 2 is a part of access port and it is part of HR VLAN. Port number 3, part of access port, it is part of sales VLAN. And port number 4, part of access port, part of IT VLAN. Okay. Same thing I will do it on second switch. On second switch again, this port number 2, access VLAN 5, port number 3, access VLAN 10, port number 15, access VLAN 15. Okay, port number 4, sorry. Let us do configuration of second switch. Let me remove all these things. Okay. First, I need to configure a VLAN database. Config terminal, VLAN 5, name HR, VLAN 10, name sales, then VLAN 15, name IT. Okay, all three VLANs configured. Exit, then interface fast Ethernet 0/2, switch port mode access. Switch port access VLAN 5. Okay, then interface fast Ethernet 0/3, switch port mode access, switch port access VLAN 10. Then interface fast Ethernet 0/4, switch port mode access, switch port access VLAN 15. Now we have done both the switches configuration. Remember, we have just done access ports configuration. This particular link, there is no configuration. It is by default. If there is no configuration, it would be by default access port part of VLAN 1. That was we have checked in our last class. If whenever the switch comes up, all the ports in a switch would be part of VLAN 1 and it is part of access port only. Okay, so let me show you. Show VLAN brief. You see all the ports are part of access 1 VLAN. Okay, now suppose if I try to initiate a communication from this PC to this PC, what will happen? Let us see. I'll go here. I'll do desktop command prompt ping 192.168.5.2. Am I able to ping? Let us see. I am getting a request timeout, right? Because what is happening? A traffic is going to this switch and this switch doesn't have any port or a MAC address or anything. It will drop this traffic because this port is part of access port. As soon as I create this port as a part of access port VLAN 5, this traffic will flow, other traffic will not flow. Let us try that also. What I will do, both the links, both the switches, interface 0/1, switch port mode access, switch port access VLAN 5. Second switch also I will do same thing. Switch 1, config A, interface fast Ethernet 0/1, switch port mode access, switch port access VLAN 5. Okay. Okay, now let us see. Show VLAN brief. Show VLAN brief. Part of access port, right? Config A, interface fast Ethernet 0/1. I'll not do any changes now. Okay, let it come to fast forward stage. Let us again do the same command. Let us see now what will happen. Let us wait. Still we are getting the request timeout. Let us see. This is part of we have
I think
configured
we have
IP
to
addresses. We have
we
not
have to
configured IP addresses, right?
in that switch also we need to configure that access port, right?
We have
VLAN.
done. We have done. We have not configured IP addresses to the PCs.
Okay.
Yeah. So let me configure that. 192.168.10.1. 192.168.15.1. This I have done. Let me do it here also. 192.168.5.2. 192.168.10.2. Again here also. 192.168.15.2. Okay, done. Now let me again try to initiate from PC1 desktop command prompt, same command. Now we are getting ping for VLAN 5. But let me try, this port is part of, remember this port as of now part of access VLAN 5. Okay. So we are getting a reply for VLAN 5. Now let me try to ping VLAN 10 desktop, ping 192.168.10.2. As of now, I am not getting a reply. Right? Let us wait. Okay. So now what I will do, I will make this port part of VLAN 10. Then we will see again same thing. Switch to 0. We will not. Okay. We will PC 0. We will check later. This port is part of VLAN 5, right? I will make switch port access VLAN 10. Another side also I will make switch port access VLAN 10 only. Switch port access VLAN 10. Okay. Fast forward. Okay. Now again let us see from PC1. From PC1, sorry, this PC I am getting VLAN 10 PC I am getting ping now. But from another PC which I was getting previously, what will happen? Let us see. This I am not getting a ping now, right? So what will happen when we have an access port and we have a scenario like this? So PCs are different VLAN PCs are spread across the access or different spread across the switches. If we have access ports only, one VLAN traffic can be forwarded at a time. Okay, you cannot have all the VLANs communicating with all the other PCs. So to overcome this, what we will do, we will configure here as a trunk port. Here as a trunk port. Okay. So what will happen when the trunk port is available? This switch will allow all the VLANs whatever available. This switch also allows all the VLANs whatever available. So now let us see if any port is part of trunk port first. Switch to 0. How you can check this? Show interface trunk. As of now, no switch, no port is showing as a trunk. Show interface trunk. Here also no port as a trunk. Fast Ethernet 0/1 I will configure as a trunk port because that is going between the switches, right? Switch port mode trunk. Okay. Here also I will go config the interface fast Ethernet 0/1 switch port mode trunk. Okay. Now let us see again what port is a show interface trunk. Now you see port number 1 is a part of trunk port status. It is a trunking status. And which VLANs allowed here? VLAN 1 to 1005 allowed. And by default, whatever the VLANs available, that will be flowing as of now. Okay. VLAN 1, 5, 10, 15. This will flow in our trunk port. Same thing will happen. Show interface trunk. You see here also these VLANs are allowed and these VLANs are flowing as of now because these are active VLANs in our switches. Now let us go again. Again, I will try to ping from this PC to another PC. I am getting a reply. I'll try from another PC and I'll try from VLAN 15 also. Then we will see. 192.168.15.2. I'm getting ping from each other, right? Every VLAN can communicate with their respective VLANs as of now, right? But the question arises now, how this is happening? How switch is sending a traffic and how this switch is receiving a traffic, what they are seeing with each other. Okay, now let us understand that particular thing. To understand this, there is one protocol on top of trunk ports. Okay, on top of trunk ports, there would be one protocol running, a tagging protocol. Okay, what will happen whenever you send any frame, you would be having a frame packet, right? This is your source MAC address. This is your destination MAC address. Okay, then whatever your data available, correct? Then your frame check sequence, if the frames are correct or not, it will check. On between this, what will do this protocol when the packet is going via trunk port? This protocol will add a VLAN tag numbers. You see a .1q protocol or whatever, it will do a tagging on the trunk port. When you do a tagging, the switch will add a VLAN number to it. Okay. Then it will send to other switch, and other switch opens this particular packet, and it will know this packet belongs to this particular VLAN. Okay. And to use this, we have mainly two protocols. One is 802.1q protocol, which is mainly used nowadays. And there was one old protocol, which was ISL protocol, which is not used nowadays. So we are not going to discuss about ISL anymore because it is obsolete. Nobody uses this and it is removed from syllabus now. So we'll discuss on 802.1q protocol. So how it tags a packet, let us understand. When the frame enters the trunk protocol, it adds a VLAN tag with the same frame. So what will happen? Suppose I have one particular switch here. Okay. I have one switch here. I have another switch here. Okay. This is switch 1. This is my switch 2. This is a PC of a VLAN 5. Here also I have one more PC with a part of VLAN 5. Now, when this PC wants to communicate with this PC in the same VLAN, we will be having here a trunk port. The traffic will come to a switch, right? After the switch, it needs to traffic need to flow from this particular link, right? So what this switch will do, when the traffic is going outside of the trunk port, it will add a VLAN number, VLAN tag as a VLAN 5. And this traffic will come to our switch again. This traffic will come to via this link to this. When the traffic received on a trunk port, switch will again do a untag. Switch will read whatever the VLAN number it is, and then it will untag and send it to access port. If suppose we have another switch here, okay, switch 3. And here we have another VLAN 5 PC. This switch, this will be untagged, this would be remaining tagged, and here also it would be remaining tagged. Okay, the traffic will be untagged only when it wants to go to access port. A switch received a traffic from a trunk port and it again need to send it to access port, then it would be untagged, or else it would remain tagged, and here it is trunk port, right? Here it will get a untagged. Okay, that is clear. Hello.
Mahendra, one question I have.
Yeah.
If there are 5 VLANs,
Mm-hmm.
VLAN 1, VLAN 2, VLAN 3, VLAN 4, VLAN 5, if we
Mm-hmm.
have free ports, free interface, can we connect? Can we make 5 different interface? You said no access different. Just a curiosity
Yeah.
question. I
We
have
can
asked
we
just.
can we can do that, but usually that is not a good practice or thing. See, from a lab
Mm,
point of view, you can do. You have switch
okay.
1, you have switch 2. Okay, here you have a VLAN 1, VLAN 2, VLAN 3. Okay, here also you have VLAN 1, VLAN 2, then VLAN 3. You can do here like 3 links. One would be part of VLAN 1, one would be part of VLAN 2, one would be part of VLAN 3. Traffic will flow still. Okay, but here just between same VLAN communication happening as of now. But later we would have a
Mm,
different scenarios. You will understand that also. Then you will get to know. Okay, but for a lab scenario, yeah, you can do that. Not an issue. Okay, yeah. So now see what is happening. 802 protocol adds a 4 bytes of header into our frames representing a VLAN ID. So you see previously this was our frame when we don't have any VLAN tagged or anything. We would have a destination MAC address, source MAC address, whatever our length data, and it will send to our switch. When the switch should do a tagging, it will add one more thing as a VLAN tag. What the VLAN tag will having? It would be having a Ethernet type. It would be saying this is a tag protocol. This particular Ethernet type means a protocol, whichever protocol it is having. Then this is PRI means priority check, which is used in your quality of service. Then we would be having a VLAN ID saying this particular protocol is doing a tag, and the tagging number is whatever VLAN 5 or VLAN 10, whatever it is. Okay. So usually it represents in a TP ID and a TC ID. tag protocol identifier and a tag VLAN identifier like that. Okay. You can see here. 1 minute, hold on. See, first two sorry. Out of 4 bytes, first 2 bytes would be having a TPID, tag protocol identifier. Then next 2 bytes would be having a CFI, which is your quality of service priority, and your CFI, which will check your MAC address and all. Then the VLAN ID would be available. Okay. Is it clear? So now let us understand how the tagging happening with the packet flow. Just now we see everyone communicating with each other, right? Now let us go to simulation, edit. I will remove all and I will just keep a ICMP. Now let us see how the tagging is happening and how the frame looks without tag and with tag. I will initiate from here. I am pinging. So now let us see when I am sending outbound traffic, what I am having. I am having a source address, what are the particular type, it is ICMP or whatever packet. Then I am having destination address and all, right? I don't have any TPID or TCID anywhere in this, right? So now let us go to next packet. I'll go to next packet. I'll open this. In an inbound, first let us see an inbound traffic. 1 minute, hold on. Okay. In an inbound, still I don't see anything like TPID or anything. In an outbound, let us see. Outbound, you see a TCID available, a TPID also available, right? What this TPID 0x800 means, it is a 802.1q protocol. Now let us see, is it true or false? I will copy this ether type. Ether type, this one, let us see. Let me search again. So what this particular thing says, 802.1 uses this particular as a ether type value. Okay. So whenever you see this particular thing in a TPID, this means it is 802.1q protocol. Okay. And usually you would see a 802.1q protocol. Then TCI, and this is our VLAN ID number. This would be actually in a hexadecimal format. You can convert into a decimal format and then see. Now we'll see hexa to decimal conversion. If I do this, sorry, I need to copy this. If I convert this, you see, this is a VLAN 5. As of now, we are sending a traffic from VLAN 5 PC, right? So this particular traffic says it is belongs to VLAN 5. Okay. Now this packet is going. What is happening? When the traffic received on an access port, there was no tag available. When the traffic is going out, see now we saw this was inbound traffic and this is a outbound traffic, right? And when we saw tagging, the tagging is available. On an inbound, we don't have any tag available. On an outbound, we have one tag available, right? TPID and TCID. If you see in an inbound, I don't have any TPID or anything, correct? On outbound, I have TCID and TPID both. After destination and source address, I have this particular field available. So this packet will go to a switch now. When the switch receives a packet, let us see what is happening. On an inbound, again, I don't have any TPID or TCID. I don't have, sorry, on an inbound, I have the tag available because when the switch send a packet, it did a tagging, right? So same tag received by a switch. Now this switch has a tag available. So this switch knows this traffic belongs to VLAN 5. And when it sends to VLAN 5, it removes the tag again. Okay. So as per our theory, what we are saying, if you go to our theory part, when the frame enters the trunk port, it adds a VLAN tag with the frame, right? That's what we are saying. When the frame enters the trunk port, it adds a VLAN tag to the frame. And when the particular trunk it exits from the trunk port, it removes the tagging. Okay, so that's what it is having, right? When it goes to particular trunk port, the VLAN tag happened, and when it is exiting from a trunk port, the VLAN tag is removed. It is removed when it is going from a trunk port out. So it will again go to a switch. Then there is no tag available when the traffic went to a PC. And PC again will not do any tagging. It is just a normal packet. Again, it will go to a switch. This time the traffic is in a reverse. Now on this switch, if you see on an inbound, we will not have any tag, but on an outbound, we would be having a VLAN 5 tagged. Let us see, because traffic received from an access port doesn't need any tag, but traffic when it is going out of trunk port, we need a tag. So on an inbound, I don't see any tag source destination and the type. But on an outbound, when the traffic is going from the trunk port, I would need a TP ID and TC ID, right? Which indicates this particular protocol is 802.1q protocol and TC ID. TCI indicates a VLAN number. How you can check this particular 802.1q? If you see interface trunk encapsulation, what is happening 802.1q, right? This particular number 0x8100 is identified by 802.1q. It belongs to that particular protocol. Okay. Then TCI field says what is our VLAN number. Let us go out. Again, we'll see like inbound, we would be having a tag available, and during outbound, it would be removed because it is going out to access port now. So same thing will happen throughout the process. I will do a real time again. We will check for VLAN 10 also again. This is VLAN 10 PC. Again, go to a simulation again. Edit filters, ICMP. Okay. Now I will ping from VLAN 10. Same 10.2 packet initiated from here. It will come to a switch. During a inbound, I don't see any tag, but during a outbound, I see a TPID and TCID, but this time the value for TCI changed, right? Now let us see this into hexa conversion. Previously it was 0x005, right? Now it is 0x000A, which means a number 10, correct? So this means now we have a VLAN 10 tagged to this particular traffic. It will go to switch. When the switch opens a packet on an inbound direction, it will say, yeah, I have a VLAN tagged with VLAN 10. Then I will send this packet to VLAN 10. I will remove a tagging. It will go here. Again, switch PC will send a traffic. Again, sorry, I will open this particular packet and show you. On an inbound, we don't have any tag. On an outbound, we would be having some tag available. It will go to this PC, this switch. This switch will open a packet. It will have a VLAN tag available, and it will send to a respective PC without VLAN tag. Okay. So any questions in this, how the VLAN tagging will happen and how .1q will help on the tagging? Hello? Am I audible, guys?
This is no questions. No.
Okay.
No questions.
Okay. So
Mahiboy, I have one question, one doubt. Yesterday I was going through that native VLAN. No, native VLAN, I didn't understood like completely.
we'll go to that particular topic also. Yeah. So Pankaj, Prabal, you have any questions or we'll move forward? Okay. Okay, then I will move forward.
Sure.
Yeah, miss, you have any question, miss?
No, I'm fine. No questions.
Okay. Just give me 2 minutes, guys. I'll come back. Hey, hi all. So now next we will go into dynamic trunking protocol. See, till now whatever trunk configuration we have done a manual configuration, right? Switch port mode trunk. But in Cisco we have an option to do a trunking protocol via via communication or via initiating a communication. So what will happen? We have two switches, assume, okay? This port between the switches should be in a trunk port. There are two ways. Either do it a manual configuration or do it via a protocol. We call it a DTP, dynamic trunking protocol. Okay, here also same thing. Either do it via manual or either do it via a protocol DTP. So what will happen if you do it manually? Okay, both side you will do a manual. But when you use a DTP, there are certain you need to use certain protocols or certain steps. See, DTP is a Cisco proprietary protocol used for dynamic trunking configuration. It has different modes of configuration to decide the port will be in a trunk or access mode. It has two modes of configuration: dynamic desirable, dynamic auto. There are two modes when we do a switch configuration. So till now, whatever we did, where it is, till now, whatever I was doing, switch port mode trunk, right? Correct. But when we are using a DTP, we can use switch port mode dynamic desirable or switch port mode dynamic auto. What is the difference between dynamic desirable and dynamic auto? See what will happen when I have, let us see, dynamic desirable actively tries to form a trunk wherever dynamic auto waits for a offer to form a trunk. So what it says, I have a switch now, right? Suppose this side I have configured dynamic desirable and this side I have configured dynamic auto. So whenever this switch will initiate a communication that I wanted to form a trunk, and this switch will reply, okay, let us form a trunk port. So these ports will become a trunk ports. Okay, but assume what will happen when both sides have a dynamic auto. This side is having a dynamic auto and this side is also having a dynamic auto. Nobody will say that I wanted to form a trunk. So this port will not become a trunk port. This port will be a access port only. Okay. And there is another scenario. If you have both sides dynamic desirable and dynamic desirable, again, this can form a trunk port. But if you have dynamic auto, you cannot form. Dynamic desirable and dynamic auto, you can form a trunk port. Okay. So we have given certain examples in what scenarios you can form a trunk port. Now let us see. So if you see, if this is suppose you have both sides access ports configure, always access, never communicate for a trunk port. If you have a trunk port, always trunk, send the DTP packets to other sides, manual trunk configured. Whatever we were doing, right? Switch port mode trunk. So this will communicate. When we have dynamic desirable, actively tries to form a trunk, can form a trunk and initiate a trunk. When we have dynamic auto, it will just wait for a forming of trunk. Now let us see. We have switch one port state. Sorry, this is switch 2 port state. Okay. So suppose switch 1 has a dynamic desirable, switch 2 has a dynamic desirable, it will form a trunk. Switch 1 has a dynamic desirable, switch 2 has a dynamic auto. Still switch 1 is initiating that I want it to become a trunk, right? So it will become a trunk. Switch 1 has a auto and switch 2 also has auto. This is wrong. This will become an access. Then switch 1 has a trunk. This is having a trunk auto. This will become a trunk port. Then if it is a trunk and trunk, it will always be a trunk only. Okay. So only scenario is at least one side you should be having a dynamic desirable or switch mode trunk. Then the trunk will happen, or else the trunk will not happen. Okay. Clear? So now let us configure a specific lab and we will see this particular things, how dynamic desirable and dynamic auto will work. We will configure a simple lab. We don't need this lab as of now. So now let us take two switches. Switch 1 and switch 2. We don't need all these things now. We just need to check how the trunk port would be formed. I will connect two links between these ports. Let us do a fast forward. Now first let us see this ports is part of which VLAN. Or first let us see show interface trunk. There is no trunk port configured as of now. Show interface trunk. Nothing configured. So now what I will do, both the ports I will configure switch port mode dynamic desirable. This I will configure dynamic auto. This also dynamic auto. Then we will see what will happen. Can we form a trunk port or not? Switch to config T interface fast Ethernet 0/1 switch port mode dynamic auto. First let me go give see auto sets a trunk mode dynamic negotiation parameter to auto. Sets a trunk mode dynamic negotiation parameter to desirable. Desirable means I want to initiate that yeah, let us be a trunk port and both will forward a multiple VLAN traffic. Auto means I don't want to be a initiator, but I will response. Suppose if you are saying that yeah, we will become a trunk port, then I will respond, okay, let us be a trunk port, but I will not be a initiator. So first let me go to auto. Okay, so other side also I will go same thing. Config T interface fast Ethernet 0/1 switch port mode dynamic auto. Both side we have become dynamic auto, right? So now let us see if we have a trunk port configured or access port is still. Show interface trunk. Sorry, show interface trunk. I don't have any trunk port as of now. Show interface trunk. I don't have any trunk port. Why it is not there? Let us see. Show interface fast Ethernet 0/1 switch port. It will give me like the switch is in what mode as of now. Administrative mode is dynamic auto. Then what it is giving me, operational is static access. It is as of now it is access port. Okay, access mode VLAN 1 by default. Okay, so now let us see show VLAN brief. Fast Ethernet 0/1 is still be part of access port only. Same. So now what I will do, switch to instead of dynamic auto, I will change it to dynamic desirable. This would be still dynamic auto only. Then we will see what is happening. Switch to config T interface fast Ethernet 0/1 switch port mode dynamic desirable. Okay. Now let us wait. The switch will go into a, it will take a couple of seconds. Let me do a fast forward. Then let us see. I will go into show interface trunk. Now you see we have formed a trunk port. And as of now, this particular mode is a dynamic desirable. Other side is dynamic auto. Still we are forming a trunk port. Show interface trunk. You see, I formed a trunk port. It is part of a mode auto, but I am having a trunk port now. We can see show interface fast Ethernet 0/1 switch port. Okay, operational mode. Now it is a trunk mode. Previously it was access port, right? Now it is part of trunk operational. Okay. So if I have both sides, one side dynamic desirable, another side dynamic auto, it can form a trunk port. If both side dynamic desirable, it will not form a trunk port. If both sides dynamic desirable, still it should form a trunk port. Let us see. Let us see if it forms a trunk port or not. This side it is dynamic desirable only, other side it is dynamic auto. So I will configure dynamic desirable on other side also. Interface fast Ethernet 0/1 switch port mode dynamic desirable. Okay. Previously it was on auto mode, right? If you go to above, you will see administrative mode was dynamic auto till it was a trunk port. Now I will go to up arrow. Now administrative mode is desirable, still it is a trunk port. If both sides are dynamic desirable, we will form a trunk port. Okay. Any questions in this? Hello?
No question.
Okay.